wanted to welcome everybody who's joining this pretty cool Designing with Soil Moisture Sensors webinar today. We have our very own Tyson Carroll presenting for us today. He is a landscape architect and a contractor with wood architecture. He's been installing and designing landscape irrigation systems for over 10 years and does all kinds of different things from small commercial to large educational stuff. So we are definitely happy and pleased that he could present this for us today. And kind of without further ado, I want to just get this kicked over to you, Tyson.
Well, thank you very much, Jake, and good morning, everybody. And I'm going to talk to you all about designing with soil moisture sensors. So hopefully it doesn't put too many people to sleep. And I'll try to do some pauses throughout. So if Jake has any questions, can answer them right up front. But other than that, let's get started. So we're going to talk first about the background and history of soil moisture sensors, our own personal experience, the theory, design components, and then kind of working our way through a set of plans, going through the plan set, detail specs, and then given a brief sort of installation process, and then through verification, then going through the flow management, and then some implementation and examples that we've done in the past, my own little personal wish list of things I'd like to see incorporated into land effects, and then with a brief recap, and then hopefully some questions. So other than that, we'll get started. So just a little bit of background on us. We've been designing for about 15 years for small, large, medium sites, everything from residential estates to public, corporate institutions and parks. When possible, we design solely with 2-wire systems unless pretty much unless the client dictates otherwise. From Baseline's perspective, we've been using their controllers and their sensors for about the last 6 to 7 years. And even though from a cost perspective, there is a bit higher cost in doing things with sensors, the proper way of doing it, we also believe that it's our job to give the best possible system to the client in the event that when this goes in, that they have a product they can manage for a very, very long time with as few issues as possible. So a brief background on soil moisture sensors. There's 7 different sensors that are in the market, and there's more coming on every day. They're used heavily in agriculture and have been for quite some time. And they're sort of relatively new to the landscape industry. And I say that somewhat reluctantly because they've been around since the early 90s. And there was some misconception with sensors. And so in the last 7 to 9 years, they've really come back and starting to gain a lot of steam in terms of their use within our horticultural industry. So the pros and cons, moisture sensors versus ET, and Jake and I have had a few spirited debates on this, and I'm not saying that one is better than the other or right versus wrong, just that there's a different way of looking at it. For soil moisture sensors, the pros are they provide data right at the plant's root zone, so you can see temperature, moisture percentage. It provides actual data underneath the soil that you can use to adjust your irrigation scheduling. And then indirectly, it incorporates the irrigation emitter type, soil type, weather, and even mulch into how that sensor reads. The cons are as placement is critical. And if you put the sensor in the wrong spot, it can cause your irrigation management to go haywire quite quickly. It takes a fair amount of time to calibrate, meaning that you can't just put a sensor into the ground and then walk away and expect it to do its job. You have to trust but verify. And then the last part of that, which sort of ties into the first two, is it can provide you with some, if not several bits of false data, meaning if the contractor installs it not per plan, or if you hooks it up to the wrong valve or whatever it may be, you can think a plant is watering and it's not, or it can be getting too much water and it looks fine. The pros of ET are is it's easily to incorporate into irrigation scheduling, can be accessed through on-site or local weather stations, and if you want it to, it can adjust automatically the irrigation based off of historic data. The downsides are can and will do it sometimes across the board, and not every valve is created equally. The information in crop coefficient is based off of turf grass, so in the times where we're doing a lot more low water use plants, you have to take that into account, and sometimes it will not take into account the on-site conditions, which the things of the soils, the emitter types, the mulch, so on and so forth. So back in 2011, we were looking to make a change to our local jurisdiction, and we met with several controller manufacturers, tested a lot of different controllers, but like anything, you sort of dip your toe in the deep end before you do the cannonball. We needed to test a site to see, how well the system would work. So for one of our projects, we found kind of on the back 40, a riparian area. It was a low profile location, which made it advantageous to try something new. The existing system was a little bit older, hybrid, so it was a good opportunity for the city to get a new controller and then try something out. It was a hybrid system, so we had conventional and then we added in 2-wire. And what we did was 3 sensors, one for the trees, one for shrubs, and one for some existing valley oaks that we had on site. And the top version of the screen was what you'll see is what it used to look like, which was more or less a dumping ground for contractors at the time. And then we just finished this up in 2013 on this project, and below are the results. So what we did was a year of trial to get a whole growing season, active management, meaning as opposed to turning it over to a maintenance contractor, we were responsible for the irrigation. We allowed it to water 7 days a week just because this was a new system and new thing for us, and we didn't want to do anything incorrectly. We enabled every single alert text message that you can get, and I can remember vividly getting text messages at 1, 2, 3 o'clock in the morning, and my wife going, "What is that?" I said, "Don't worry, it's the controller. It's just doing its job." But for me personally, it provided that security blanket, knowing that the system was doing what it entailed. And what we found out after the year of management was we had stretches of 139 days where we didn't water for the trees, and almost 181 days where we didn't water for the shrubs. And now, granted, we had a few intermittent rains in certain times that made it this possible, but we were completely blown out of the water of how much water, how much time we were able to save through this system. And then looking at the plant performance, we couldn't believe the results that we were getting. So the challenge with sensors in any system is how do you bridge the application with the academic? And we have all this literature and research that says plants grow when the temperature hits this condition, it stops when it hits this temperature, but we don't really have we didn't have the ability to see those things. But what we saw with the sensors is we could see what 5 inches of mulch layer does to the temperatures in the middle of summer. It allows us to see what's going on at the plant's root level, so temperature, moisture. It allowed us to hydrozone things with each sensor based off of a program, and then it provided us actual real data that we could use to make our irrigation schedules and maintenance decisions. So the theory behind designing with soil moisture sensors are you kind of start out with the macro and then you get into the micro, as you almost have to look at this from the standpoint of you are a maintenance contractor, you need to program this thing. So you look at one sensor for each program type. So if you had rooftop gardens, that gets one, bioswales gets one, shrub area gets one, turf area gets one, so on and so forth. You then have to go through what's your plant palette. Do you have a kind of meadowy type plant palette? Are you looking more on the southwestern Mediterranean? Are you going to do more turf or more succulents? Then you get into the Sunburst Shade, where especially when you get into multiple layer buildings, do you have awnings? Do you have existing trees to where you're going to have a lot of shade, or do you have a lot of buildings surrounding your site to where you're going to have a lot of different solar aspects to where the sensor may read higher in one area and then lower another based off of that position? Then you get into plant sizes. Where are you going to be designing with just plugs? You're going to do a 15-gallon, 36-inch box or a 144-inch box. And where you want to place the sensors, you almost look at what's the biggest value, what's the biggest bang for your buck. Are you going to program a 144-inch box tree to run off a sensor that's a 15-gallon? Then you get into soil types where sand, silt, clay, loam, it all affects how the sensor reads and what kind of data that it's going to provide, how quickly your sensor is going to spike. The other thing we've learned through the process is that the nursery production methods really do matter. So you might have a clay site, but your root balls are a sandy loam. And so where you place that sensor and how you interpret that data will vary greatly depending on where you put it. Next being is going through is the upper and lower limit, which is a function with the baseline controller and the sensor. And what the lower limit means is when you set the percentage to run, it will not start until it goes below that. The other option is to do an upper limit, meaning the sensor is going to want to run every single day or whatever days you select, and then it will stop when it hits that percentage. There's not necessarily a wrong way. There's not a right way for this. A colleague and I in Oregon have argued over this consistently for the last couple of years. He believes in upper limit. I believe in lower limit. There's really no right way or wrong way to do this. It's how the sensor is going to react with the controller will vary. They do say, although a lot of the more drought tolerant plants want the dry down, turf grass, for instance, they will do the upper limit to where they want it at optimum field condition moisture, where you're not going to create a muddy mess and you're keeping things just pristine and at a certain percentage as much as possible. So now going to the components of the system, you've got your lightning arrest or your valve. We always recommend in any system with 2-wire, you put it in conduit, preferably 1.5 inches inside, especially when you have a lot of bends, curves, long runs. You have your decoders, and then you have the baseline sensor itself. So you start out with your plan, and this is a job we did locally for a higher end multifamily project where we had trees, shrubs, a rose garden, planting beds, turf. And so when we looked at this in the beginning, it's like, okay, we're going to have, 5, and in this case, there's 6 sensors, one that's not shown on here. And so where do you really want to place them? And so for us, we started out as, okay, what's the best area for our trees and shrubs? And in looking at it, we have a block wall on the western side. And so, okay, we're knowing that that's going to get a lot of heat. That block wall will heat up as well. It's next to pavement, asphalt, sidewalk. We put our tree and shrub sensor in this location on the upper left-hand side. Then we moved into the rose garden gets the sensor, the box gets the sensor, or sorry, the garden's box gets the sensor, and then the turf. So that kind of starts out our process there. Then you really move into the sort of devil in the details is the irrigation details. And this way reinforces where the placement of the sensor is really, really critical. And so we need to be able to provide as much information to the contractor so that way they install it correctly, so it's going to give you those proper readings. So for overhead, for instance, you wouldn't want to place your sensor next to an emitter or out in the back 40 where it's going to provide you false data. You're going to place it right in the center, equidistance between 3 heads, preferably, to where it's going to give you a real-time reading of, okay, this is what our head-to-head coverages look like. And with the sensor, you would want to install it in conduit from the valve all the way to the sensor. In the event that you have to, and we don't recommend it, if you're over 50 feet, you put in a splice box. But the general idea is that if you can get your valves located within that 50 feet, it makes it a cleaner connection from the sensor to the valve. That way you're not going to have a loose connection, faulty grease pack, whatever it may be. The next detail is going into more of your point source irrigation. Same sort of concept applies from the valve to the sensor. In this case, same as the overhead, is you wouldn't want to place your sensor right next to the emitter, because when that thing waters, you may only water it for 5 minutes and it's going to spike and say you've got enough water. Whereas on the other side of the root ball, it's dry as a bone. So you place it on the opposite end. You would preferably want to try to angle it down to get a true profile of the root zone, and then you would irrigate it and see it spike. The depth of the sensor can vary, and it will vary depending on your root ball size, ultimate tree height, or size that the tree is going to grow. And you can have it right at the surface to see where the 6 inches of roots are going, or you can have it to the bottom 2.5, 3 feet. There's not necessarily a right way or wrong way. It's just you'd have to make sure that when you start irrigating that sensor is going to spike and say, okay, this is enough water. And what we tend to find out is that you don't necessarily apply more water more frequently. It's just at the initial application, you sort of figure out, okay, it takes 5 minutes, 2 hours for the water to get from the top of the root ball down. So you're getting a complete profile of watering. The next version is when you get into multiple points of point source irrigation. And again, the same concept applies as if you have 2, 3, 4, 6 bubblers, you're going to want to locate this thing equidistance in between those 2 emitters. And that way, when this thing waters, once water hits this location right here where the sensor is located, you've got water all around that root ball. Because the worst thing you can have happen is, again, if you have it next to the sensor and you're thinking that thing is getting watered, and there's nothing worse than showing up and you have a tree that's dropping leaves in the middle of summer. The next detail is of a drip spiral detail that we did, and location matters ultimately where these things go. You want them on the outer or in between the last ring or the last 2 rings, and depth again can vary from below the 6 inches below the drip rings to all the way to the bottom of the root ball. We tend to err in the middle to where we'll go halfway distance, which would be anywhere from 12 to 18 inches. And then again, you water it up and see when the sensor spikes. It takes a couple applications to figure that out. You might incorporate cycle soaks in that process, but that sensor really provides an eyes below the ground where you can see that, okay, this thing's going to take 30 minutes of water and 60 minutes or whatever it may be. Last details of just the inline drip, more common, at least for us, doing plug planting, meadow planting, smaller perennials. And it's the same concept as the spiral detail, where you locate the sensor in between 2 rows, you get it down, and usually in this case, if we're doing inline drip, our root zone for these trees is going to be a little bit, for these plants is going to be a little bit of a smaller area. And so we'd set it anywhere from 6 to 12 inches below and let it go. Then we move into the boring part of any set of plans, is the specifications. And what we found through the years is that when we as an industry put in per manufacturer spec, in reality, that really only means that you need to have power to the controller. And if it is 2-wire, the system needs to be properly grounded. If you don't have information about the installation, about the management, and about the programming, you can show up to a site that is just scheduled to turn on and off. Sensors aren't enabled. Flow management is not set up to where there's a break, it's going to shut down. And so to really get the power of this system and maximize its abilities, we have to take our specifications one step further and ensure that the contractor, when they leave the job, that they're providing the owner a fully operational system that will do what we as specifiers sold the clients on. And again, going through the specs, one thing that we've started doing as I don't know if it's necessarily a CYA, but to make sure that I's are dotted, T's are crossed, is that the controller should be certified. The contractor should be a certified installer. Getting moisture sensor maps is critical, because once those puppies are below the ground, it's a challenge to find them. And then using the feature of the GPS locating, where you're marking your valves, you're marking your equipment, you're marking the sensors. And so that way, if you're managing this or operating it from remotely, you can at least have an idea of where things are located, because ultimately at some point, construction will happen, repairs will be put in, plants will be added, and it's better to know where things are at below the ground versus having somebody inadvertently cut things and cause more of a problem. So this is an installation that we did with one of our crews for a repairing project, and got everything trenched. We had a bunch of old existing valley oaks that hadn't had water ever. We believe they were most likely surviving on flood irrigation from the row crops adjacent to this site. So we get our trenches in, get our conduit in, and again, we specifically use 1.5-inch conduit. You can get away with like inch conduit if it's a pretty small straight shot, but if you have a lot of bends, a lot of curves, we found that 1.5 inch has a big enough ID opening that you can pull these systems through the wire through relatively easily, and it makes it to where if a sensor fails, the replacement is quite easily. And we actually had one on this site that failed on us, and ripped it out, returned it, got a new one from the manufacturer, and went and put it back in, and we were back up and running in maybe 25-30 minutes. From there, you pull wire back. You'll do some sort of preventative covering for the conduit so water condensation doesn't get back through, and then you get ready to hook up your sensor. Once it's through, you drop it in the ground. We weren't able to show it here because I couldn't find the photo. Is that once it's settled, you'll hook it into the system, and then you'll do the bucket test where you'll test the sensor and it'll show some sort of reading, and then you put the bucket of water on it and sensor will spike, and then you know you're ready to go and start backfilling. Afterwards, you before you want to make sure that that sensor is angled up. If you look on the photo on the right side, he just put it down there, but more times than not, sensors will get installed incorrectly, and you want that thing facing vertically, and you can see our supervisor on the right side has that angle down. Then you start backfilling. You put your covering in there for the conduit, just again to keep the moisture condensation from coming through. You can see on our valve manifold setup, we have a ball valve on the back side. That way we can isolate that thing if something ever were to happen. You see the lightning arrestor kind of floating around in the background, and then you see the union on the outflow side. So in the event there is an issue with this valve, we can isolate it, fix it, and repair it in relatively no time. So what we found through this process the last several years is that verification is key, and the industry standard for any sort of maintenance period is 90 days. And depending on the time of year when this gets installed, in winter, for instance, that 90 days is really not enough time to get a system calibrated, make sure it's operating correctly. And so we've been able to convince a number of our clients that, really 6 months of maintenance period is a way to go, because you don't want to have the owner inherit a set of problems and then for them to come back and say, well, your system doesn't work. And when in reality there was an install issue, or they just needed time to calibrate the system. That moves to the next point of calibration for the sensor is key. Every soil, every area will vary in what is the sweet spot of the sensor. We found areas where 19% looks great, or upwards of 29-30% is ideal. And the reality is that the plant performance will tell you what your percentage is. So looking at the plant, looking at the sensors, like, okay, you will realize after that 6 months that this is the way, the percentage we need to go off of, but you're not going to get it in 90 days in most cases. Once that's done, you can program sensors to run off and you're ready to go. Ideally, before the contractor walks off the site, flow management should be enabled, and that goes back to it better be in your specs and details. Otherwise, there's a good chance it won't get done. You need to have your high flows, your low flows, your unexpected flows enabled. Moisture sensors percentages should be set in place with verification, obviously. And then especially in the beginning, alerts are very, very critical. I've had more times than not where seeing a sensor not turn on or turn on a system and having that text message, that email makes you realize and almost sleep better at night that the thing is doing what it's intended to do. And then back to, again, plant performance is critical to what you set your sensor percentage. And the last couple jobs we've done, we'll tweak a sensor percentage a couple times during that first year, trying to figure out what that sweet spot is. And you can, if you go too low, you're going to get dry out. If you go too high, you might get things watering, especially our low water use plants, too much. So this is the part where we like to say my implementations, or known as my screw ups, and things that we've learned through the process and the years of how to avoid some of the pitfalls that we ran through, especially early on, and getting this system right. Meeting with the owners and the contractors is really critical. You're selling an owner on an idea and how this system is going to save them time and money, and so you need to convince them that this is the right way, and you need to show them that you know what you're doing. The same goes for the contractors, and that you meeting with them in the beginning to line out expectations, show them how to do it, what the pitfalls are of the systems is really key, because if they don't know how to do it, or they don't necessarily understand, they're not going to install it correctly, and then you end with things dying, and that doesn't reflect on anybody well involved in this project. I would start with smaller jobs. It's much more controllable if you have a handful of valves versus 200, and it makes it to where you can manage and kind of see the system completely at how it can operate and how it can do well. Don't overcomplicate your site with sensor placement. You can get really into the weeds when you start thinking of hydrozoning too much, and when you put too many sensors into the ground, you got to go back to think of, how am I going to program this thing, or how is a contractor going to program this thing? And so the more sensors you add into it, the more programs you're going to have. No more than the contractor. We've found through the last few years that there's a kind of hole in the industry on the transition from the design to the implementation, and it really helps both the contractor, yourself, and the owner if you know your system in and out and can troubleshoot things when they come up. And it's easier to work as a team with the owner, the contractor, and the maintenance contractor to get this system right. Design your irrigation system for maintenance, and especially for maintenance programming. If it gets too complicated for anybody, we tend to revert back to what we know, and you end up not utilizing the system itself, or at least the ability for what the system can do, which kind of ties into keeping it simple. Don't overthink it. Don't make a mountain out of a mole. And if you can't understand how you would program this, more likely than not, the contractor is not going to know it either. So the next screw up goes back to what I said earlier, in that try to install a sensor as close to the valve you want it to as possible, and minimize your pull boxes. It makes it cleaner. It makes it troubleshooting much faster. The other item would be put the sensor, if at all possible, to the valve in the area it waters. We've had a few projects that they plan showed one thing, but then the contractor decided he was going to put it to the closer valve. So I was watering what I thought was subsurface drip, and it turns out the overhead watering was actually the one that was affecting it. So it was 2 to 3 weeks of trial and error trying to figure it out, and ultimately we had to dig it up and move it. And the last and one of the most important is your percentage needs to be verified. Don't put a percentage on there and on your plans and walk away. It really needs to be verified by the contractor and set up to the way of, you want it to water before it gets to the wilting point and stop before you reach field capacity. And there's a wide range in between of what that specific percentage is, or what the optimal percentage is. So here's a couple of examples of projects that we took over the irrigation management on. There was a series of Swan Hill olives that we were trying to keep going in a very highly pedestrian urban area. And so we took over in December of 2017. and just started watching. And we enabled the sensors and watched. And it took about 6 months, April of, I want to say last year, to where we finally realized that, okay, the sweet spot for these trees, inline drip in pavement with clay root balls, was about 28, 29%. And you'll see on the graph on the upper right-hand side, the system waters and it spikes, and it goes down and then it spikes. And then you look at the graph at the bottom, this system to date hasn't watered since November of last year. And it's, in some ways it would come across, yeah, it's common sense not to, water during the winter time, but with newly planted trees, you don't know. And this kind of gives us that eyes below the soil where we can go, yep, the tree looks good. The percentage is at 30%. It doesn't need to water. And it provides that sort of, again, that security blanket to where you can see what's going on, not only at the plant, but also at the plant's root zone. Same thing, we had a site where we were missing a few sensors in critical places, and we chose to install a sensor at some specimen arbutus trees. And it took a little bit of time to figure out watering time, and it was a sandy loam root ball with a clay surrounding. But once we figured out what the run time was with the cycle soak, during the middle of summer, it was watering, or 2 to 3 days a week, and the sensor will spike, it'll go down, and then we would go and verify and say, yep, the plant looks good, it's recovering fairly well, and it makes the system somewhat autonomous once you get that squared away. So this gets into my wish list for land effects. Whether they accept it or not, we'll find out. Part of the thing of putting in the moisture sensor blocks is they're, for the most part now, just blocks with some limited information. But if we could have it to where it would become a smart block, to where when you dropped in a sensor in a location, you could assign valves based on the plant use to where, or plant type, and generate a schedule that would show, okay, these valves are all associated with trees, shrubs, and so forth. In my opinion, that would make it much easier for the contractor to know how you intended as a designer to program this thing. If we could, again, assign it based off of the different tree types, or the different plant types, it would make it, especially the verifying of it, once you got done with the project or before you went out to bid, you could see, okay, I've got everything in place, or no, I'm potentially missing a sensor. I need one in a different location. And for me personally, it would be more of a checks and balances on the design before you send it out to plot. If we get a programming schedule based off the sensor location that would sort of tie into the program itself, to where, again, it would be another tool that the contractor could use to make sure the system goes in as placed. And lastly, the one other item that would be helpful would be to have a piping call out, or piping function. If we could do that with wires, to where we could connect the sensor to the valve, and that way there's no misconception from the contractor of what you intended to do, and avoid that issue that we had on a couple projects where they'd hooked them up to different programs or different valves, and it made the scheduling maintenance side of things a little bit more problematic. So to recap, design it as though you're going through doing the programming yourself. It really kind of changes the way you look at things in terms of where you put your sensors, how many valves you're going to have, and how many programs that you intend to have. Keep your layouts as simple as possible. It's too easy to overcomplicate things, especially in what we do. And the easier you can make it for the contractor to install, the easier it is for the owner to end up maintaining. Devil is in the details, and that having a good set of details that clearly show or lay out what your overall intent was is critical. Because if you expect the contractor to install it correctly just based off of a plan thing, more times than not you will probably be disappointed. So it's part of our job to give the contractor as much information as possible. And if we don't do that, then in some ways we have to accept the results, right, wrong, or the other. And lastly, but probably most important, is verification. If we don't verify these systems are installed correctly, whether it's through construction observation or through a more secure set of specifications, we're not going to get the product that we sold the client on, and we're not going to see the results. So that ends the webinar. So Jake, I'm assuming it's time to turn it over to you, see if there's any questions.
Absolutely. So I want to take the time here to just let everybody know about the Q&A. If you haven't typed in your questions yet, please get those over to us. We definitely have a little bit of time to answer anything that you might have in regards to this, but I have a couple here that I want to see if we can cover. So first one is actually goes back to kind of the installation of things and regarding the wire itself. Does it absolutely need to be in conduit, or is there a direct burial version, or what's the pros and cons with that?
No, it comes stock with 50 feet of wire. The pros of the direct burial is it's fast and it goes in quickly. It's a little more economical than doing conduit, but more times than not, because these sensors are located fairly below the surface, it's very, very easy for a contractor, especially on plant replacement, to cut those wires, and then you end up having to dig everything up and run it back to the valve. So not only have you lost the sensor, you've destroyed your landscape. With the conduit, once it's in the ground, yes, you still can technically, break it, but it makes it much more, it gives you much more longevity to your systems.
Cool. Now, you sort of answered this one a little later in your presentation, but how long does it usually take to get a proper or an accurate reading on a sensor?
You'd want a season, and it'll really vary when construction starts, and we don't have really control over that. But if you can get through a spring and a summer, which you're talking, roughly 6 months, that's really the time frame which you would ideally want to be able to do it, because what the readings you get in winter time, it'll just show you the percentage, and a lot of the plants are shutting down. And so you really want to be able to see that transition from winter to spring to summer, or spring to summer, to where you know what that plant wants and needs. Does that make sense, or does that answer the question?
No, that's great. So in your specs and stuff like that, are you outlining that either the contractor is to report back during a frequent visit type of a thing, or how would you monitor or maintain that to make sure it was actually done?
That gets a little, that's the sort of tricky part of you don't want to necessarily dictate to the contractor what percentage to install a sensor on, because you then open yourself up to a whole world of headaches and problems. And so what we've found using baseline sort of technical support documentation on installing moisture sensors is that we use the industry terminology of that we want the system to turn on before plants reach field or a wilting point, and turn off before the soil reaches field capacity. So there is still verification that goes on into that process and through the maintenance period itself. And so if you have the ability to and the desire to have access to the system without obviously changing things for the contractor or to the system, you can yourself can see through those times of the year, whether it's through your site observations or before the transition from the maintenance period to the owner, of okay, what does he set the percentage at, and what does it look like? And then you can go back and look at historical data from the controller and the sensor to go, okay, he adjusted it from here to here. You can print reports that show from the system's inception what the contractor did, and you can kind of follow any kind of adjustments they made and find out, one, did they make the changes, and two, what is that sweet spot for the system based off of, your final observation.
Cool. And maybe a piggyback question on that one too is, from a maintenance of the soil moisture sensor, is there a frequency that you should be going out and just checking how it is been installed or sitting so that it's reading properly? Because you can look at the data all day, but when it comes down to what it's actually reading, how often do you have to go out and check those sensors?
If you do the initial check at the install and see that the system is installed correctly, or the sensor is installed correctly, unless there's some sort of mass catastrophe construction or whatever it may be, the sensor is really going to just do its thing and report back data. The thing that's nice with the system is because of the way it's set up, it will at least indicate to you if there's a connection failure, if the sensors, potentially at times they can go out, not often, but it'll show you, yeah, there's a fault, there's an issue with the system. If when you run the reports and you can merge them to the sensor data and the controller data or the valve data, if you're not seeing that nice spike that I showed earlier, that's a pretty clear indication that there was an incorrect install, because ideally you want to see that spike and dry down, spike and dry down. If it's sort of flat lines through the whole thing, you've got a problem. And you can see that at the moment the first irrigation goes. Sometimes the issue will be the contractor didn't apply enough water, and so it's not getting to that sensor. So that's really the kind of checks and balances on the system that you can use to where it's like, okay, either we have an incorrect sensor install, or the contractor is just not watering enough to get to that sensor area or sensor depth.
Got it. So it's basically like an EKG where you can read the life of the deal there. So I like that. So we got another one here. Why does the sensor have to point up?
That's the way it's set up in terms of how, and this is a little more technical than I have the information for. Baseline would answer it much better, but the way that the system is set up, or the sensor is set up, is if it goes flat, it's something it reads from top to bottom, and if it goes flat, you're going to see kind of one. You're not going to see the dry down to the same extent as you would if it goes vertical. It's those wires run perpendicular to the sensor.
That makes sense. So I've sort of got a two-part question here. So would you ever, or can you even add more sensors to a single area? So say you got a larger zone that's covering like a really wide range. Would you ever put multiple sensors there for the one valve, or is it just based on the one?
You can put multiple sensors to a valve or into a specific location. It really depends on what your intent is. We've had it before where we'll do two sensors at two different depths in two different locations. One because it's a larger growing Quercus agrifolia, and another one is a 15-gallon shoe mart. And so you still have to. It'll provide you the data as far as what's going on within the soil, but it's still your job to decide, okay, am I watering to this sensor to that sensor? You can set it up to where, for instance, if you had two sensor depths, you could program it to where, okay, I want you to water when it goes below this percentage, but stop before it gets above the other percentage. So you can skin that cat any number of ways. It goes back to how complicated is your site, and how complicated do you want to make the programming.
Okay, and that kind of leads into this question then, which is how many sensors is ideal to have? So
how long's a piece of string?
That's a very vague question, I know, and it ranges. So I'll let you kind of.
It'll vary based off of all the variables that we talked about earlier. If it's a flat site and you have three different plant types, then obviously you do three. If you get into rooftop gardens, bioswales, turf, trees and pavement, that sort of thing, you're going to have 5 to 6. If you get into add the condition of having slopes, you might have some at the top of the slope and some at the bottom of the slope. So it'll vary based off of the site will really dictate how many you want to have. And the thing that's nice with the system, you can keep it minimal. And let's say you have slopes, you have rooftops, you have all that. you can adjust your percentages of the watering for, say, the stuff at the lower slopes, if your sensor's at the top, and go, okay, this is what, I'm watering to this, but knowing that at the bottom of the slope, it's going to obviously catch much more water and hold much more water for a little bit longer period of time. So um, you could, we've had some where we do 3 sensors. We've had some we've done, 22 sensors. It just, the site really dictates what you should do and then how you would want to program it.
Perfect. I like that answer. Um, and then maybe as a final deal, maybe if people have their final questions coming in here, we're going to wrap it up here. But from a detail perspective, I know you've been generous enough to create some great remediation details, and the details that we saw today are very, very helpful. So is that still something that we are saying we can work on getting available there, or?
Yeah, our belief in sort of like land effects is our job is to give the best fishing pole out there, or at least what we see as the best fishing pole. And so it's ultimately the specifier's responsibility to use it and then tweak it, if necessary, based off of cost constraints, client constraints, site constraints. So, yeah, no, we plan on, giving them to y'all if y'all want them. And so, yeah, we spend a lot of time, energy, and some frustration creating them through different projects. So, yeah, we're more than willing to give them up.
That's awesome. And obviously, from a wish list perspective, Land Effects hears things and does the best to implement some great tools. So, we'll work with you on the side of that as well. So, but anyways, it doesn't look like there's any more questions, and it is Friday. We're 10 minutes early from the hour, so I would consider that a win. Thanks again for doing this. I hope it was helpful for all the people who joined today. It was a great little mix of people there. So from a detail perspective, we'll keep you posted. They will be a part of the Detail Explorer, somewhat of the standard or typical irrigation details. So we'll get all those cleaned up and get going. So have a great weekend, guys. And thanks again, Tyson.
Thanks, Jake.